Welcome to my channel. Today we're looking at the cross product of unit vectors I, j, and k. The word unit vectors here means these are vectors of magnitude 1. So the magnitude of these vectors is 1. And I've drawn them here in figure 4. You can see that this is my vector I, vector j, and vector k. That the magnitude, the distance from the origin, this point, to this point is 1. And the distance from here to here is also 1. And then the distance from the origin to k there is also 1. So these are unit vectors. Now, what we want to do in this video is to find the cross product of these unit vectors. So I begin with the cross product of I, the cross I. And I know that by definition, this will be the magnitude of I times the magnitude of I sine theta with u, where u is a unit vector perpendicular to I cross I. So this is a unit vector which is perpendicular to the plane that has I and I. Now, so let's see. This is I and itself. I and itself. The angle between I and itself is 0. So, of course, what we then have here is the magnitude of I is 1 times the magnitude of this other I, which is also 1, and then sine 0, which is 0. And therefore, what that means that the whole of the right-hand side will be 0. So that I cross I will be 0. Similarly, doing the same thing, J cross J, the angle between J and J is 0. So, in fact, this is supposed to be the magnitude of J times the magnitude of J sine 0 with the mu times u. So sine 0 is 0. So the whole of the right-hand side again will be 0. That means J cross J will be 0. Similarly, K cross K will be 0. K cross K is also 0. Now, what about if I multiply different vectors? I've been multiplying I times I. What about I times J? So I times J is the magnitude of I times magnitude of J sine theta. But you realize that I and J, the angle separating them is 90 degrees. The angle between these two is 90. So that is sine 90. Then times mu. But what is mu? What is mu? Mu is the most important thing here. That is the direction that is perpendicular to this plane. So we have this plane of the plane between the plane of I and J. The plane of I and J. The vector that is perpendicular to this plane is vector K. Vector K is perpendicular to this plane. And this one you can find by using the right hand rule. You can use the right hand rule to find a vector that is perpendicular to this plane. So what we do here is that if your thumb faces this direction of the first vector, the direction of the first vector, which is I, because I'm looking at I times J. If your thumb faces this direction, and then your first finger faces the direction of this other vector, the second vector, and then you fold the rest of the fingers. So the thumb pointed this direction, The first finger points to this direction, and then you fold the other fingers. Where will they be facing? So when you try that, and you'll see that the other fingers, when you fold them, they'll be facing this direction. They'll be facing this direction, you fold them. So they'll be facing in the direction of, they'll be facing the direction of K. So the thumb faces in the direction of X, and then the first finger faces in the direction of I, or the thumb, the direction of I, and then the first finger faces in the direction of J. Where will the folded fingers be facing? And so you notice that the folded fingers be facing the direction of K. And K becomes the direction of I cross J. So this, instead of U, I should write K. I should write K. Now, what is sine 90? Sine 90 is 1. So what you have here will be the magnitude of I is 1. The magnitude of J is 1. Sine 90 is 1. And then the unit vector in the direction of I cross J is K. So what that means, therefore, is that I cross J is K. And that's what I got here. That's what I got, that I cross J will give us K. Now, what about J cross K? Let's again do that. J cross K will be given by the magnitude of J times the magnitude of K sine 90 nu, or U. What is U? U is the vector perpendicular to the plane of J and K. So the vector perpendicular to this plane of J and K is, of course, I. Is I. So instead of U, we have I. And you can see that I is perpendicular to this plane. Of course, you can still use the right hand rule, where your thumb will be facing J and your first finger faces K, and you fold the other fingers and their direction, they'll be facing in the I direction. So if the thumb faces J, and then the first finger faces K, the folded fingers will be facing in the direction of I. And so I becomes the unit vector perpendicular to both I and J. So what we get here, the magnitude of J is 1, the magnitude of K is 1, sine 90 is 1, then times I, and so this gives us I. That means J times K is I. What about K times I? K times I. It will be J. It will be J, because J is the vector perpendicular to both K and I, perpendicular to the plane of K and I. So K and I, this is their plane, and so the vector perpendicular to this plane is J. And therefore K times J, no, K times I is J. Now, what you must have noticed is that I was multiplying them in the anti-clockwise direction. that I multiplied I times j and got k. And then in the same direction, I multiplied j times k and I got I. And then in the same direction, I multiplied k times I and got j. So I was multiplying them in this direction. I was multiplying them in this direction. I times j, j times k, k times j times I. Now what about the other direction? The other direction, what do you get when you multiply j times I? When you multiply j times I, do you get k? No, of course you're going the other direction. What you're supposed to get is negative k. And what about I times k? I cross k. I cross k should give us negative j and not j. What about k cross j? K cross j should give us negative I. Should give us negative I. So what that means is that the cross product is not commutative. Is not commutative. That is, and as we've seen, I cross j is not the same as j cross I. It's not the same. Because this was giving us k, but this one gives us negative k. So therefore, the cross product is not commutative. Is not commutative. And that's a very important point for us to note even as we continue with this video, because we'll be using that in most of our examples. And let's see what I had written before. Of course, I had said that the cross product is not commutative. That is in part C. And this other part, I had already said that k is the direction of I cross j. And therefore, I cross j is a vector of magnitude 1 in the direction of k. And therefore, we got that I cross j was k. In a similar way, we found that j cross k is I, and that k cross I is j. And then we proceeded and found that j cross I was negative k, and I cross k was negative j, and k cross j was negative I, which means the cross product is not commutative. Now, so there's a simple way of identifying the solutions. That if you're asked to find I cross j, the simple way is to come up with this type of scheme where you have I with an arrow pointing to j with an arrow pointing to k. Then again you repeat I pointing to j, pointing to k. So if I'm asked I times j, I can see the direction I times I from I to j, this direction. The solution becomes the next unit vector there, which is k. What about j times k? J times cross k. J cross k, you see this is the direction. It's facing this direction. So the solution is the next unit vector, which is I. What about k cross I? K cross I, this is the direction, and therefore the solution is the next unit vector, which is j. What about the other way? The other way is where I want K cross J. You notice that K cross J is not in this direction. It's not in this direction. Because this direction, this is J, then K. But what we want is K first and then J. So K first and then J. I can pick this K and then J. You can see that I'm going in the opposite direction. So the solution will be the next vector, but now the sign is negative. I'm going the opposite direction. Or you can even use this. K and then J. K and then J, the solution will be I, negative I. What about J cross I? So again, you notice that it must be in the opposite direction, not in the forward direction. So this is J, then I, going the other direction. So the solution will be negative K. What about I cross K? I cross K, and again, the opposite direction. This is I going to K. So the solution will be J negative. That is the solution. So this it makes our work easier on how to find those products. So let's look at the examples. So the first example that we look at is if you're given vector R, which equals to J, and vector B, which equals to I plus J, the question is find R cross B. Find R cross B. So R cross B, let's just do it. We need R cross B. This will be given by R is J, and then there's a match. Cross B, and B is I plus J. So just do this, and bearing in mind our multiplications above. So what we get here is, when we distribute this, we would have J cross I plus J cross J. And what this gives us, J cross I, we already know that the answer will be, this is J, I, so the answer will be negative K. What about J cross J? J cross J is 0. So the solution here is negative K. That's the solution, negative K. Just look at another example. And that one, I had done that question. That is how I did it. So the other example is here. And the question is, if R is given by 2I plus 3K, and B is given as 3I plus 7J, can we find R cross B? And yes, we can. So I took, this is my R, and this is my B cross. So 2J cross 3I. So 2 times 3 gives me 6. Then I have J cross I. So the order must be followed. It's J to the left, then I to the right. So the order is very important, and you know that the cross product is not commutative, and therefore the order is strictly followed. Then next we should have this 2J cross 7J. And so 2 cross 7 is 14. Then there's this J cross this J. J cross J. Then plus 3K cross 3I. So 3 cross 3 will be 9. K is to the left, and then I is to the right. So that is K cross I. And then next will be plus 3 times 7 will be 21. K cross J. So let's see. It was I, J, K, I, J, K, and the arrows were this way. These were the arrows. So we want to see. Of course, we already know that J cross I, we're moving to this direction. The answer is negative K. That's why you find that this, I wrote it as negative 6K. The negative is coming as a result of J cross I, which is negative K. Then next, J cross J is 0. So the whole of this becomes 0. That's why you can see this 0. Then next I have K cross I. K cross I here is in this forward direction. So the answer will be positive J. So this becomes 9 times positive J, which gives us 9J. Then this other one is K cross J. This is in this opposite direction. K cross J. The answer is negative I. And that is why you see that I have 21 times negative I, giving me negative 21I. So when you simplify this, what you get under interchange, you get negative 21I plus 9J minus 6K as the answer. So that is how to multiply or to find the cross product if you are given two vectors. We'll look at other examples on how to get the cross product in our next